Good morning and welcome to this Mr Mickleburgh's Maths World. This is the way it is. Today I wish to speak to you about the rules of differentiation. And this will be our first lesson in the rules of differentiation, following on from the lesson we had on differentiation by first principles. Basically, we've got four rules here, which you don't really need to be remembering, to be perfectly honest, but I will take you through examples of each rule in operation. Okay, so the first one is really saying this, actually. I'm going to put my answer column over here, and the first rule is just saying that if you've got a function x raised to some power, you reduce the power by 1 and put the power down there. Okay, it's that easy. So in this case, f dash x is going to equal 10x, and you're going to raise that 10. You're going to decrease it by 1 to 9. That easy. Okay? F dash x equals 10x to the power of 9. Was that easier than first principles? I think so. Okay? Now, what's our second one? Well, our second one's saying that if there's a coefficient in front of your, in front of your x raised to some power of n, it doesn't make much of a difference. You simply take the exponent and multiply it by a, like we've done there. Alright, so in this case, f dash x I should say, is equal to 8 times negative 3. 8 times negative 3. So it's equal to negative 24x, and you decrease the 8 by 1, so to the power of 7. Again, much easier than using first principles. I think you'll find. Okay, the third rule is saying that the derivative of any constant, that is just a number, is going to equal 0. Alright, so it wouldn't matter what my number was here in example 3, my derivative would equal 0. And why that is, fellas, is that if I may just use this as a use this area here. If I've got some number, c, positive or negative, it doesn't really matter. I'm going to make it positive though, and fx equals c, well that maps out a straight line parallel to the x-axis, doesn't it? And so we know the derivative is really just another name for it, the gradient function. So the gradient of a straight line that is parallel to the x-axis is always going to equal 0, and it doesn't matter where that straight line is that's parallel to the x-axis, the gradient's always equal to 0. So that's rule 3. Now, rule 4 is really just saying that a derivative of a function is equal to the derivative of each term of the function. Okay? Now that makes it very easy to differentiate functions like that. This is the one we did via first principles in the previous lesson. We're going to see how easy it is actually to find the derivative of a seemingly complex function. So we just differentiate term by term. So the derivative of 4x to the power of 2, because of rule 2, is 8x. You decrease that exponent by 1. X to the power of 1 is just x. Okay? Alright, the derivative of negative 2x, well, that's just negative 2, isn't it? Because really, working out up here, that is 2x to the power of 1. What you're doing is taking that, multiplying it by the 2, reducing the power of x by 1, so it's x to the power of 0, but x to the power of 0 is 1, so you don't need it. Alright? So, minus 2, and then the derivative of a constant, as we've just seen, is 0. So that is my derivative. Much easier than using first principles. Thank you, Joel. You may turn it off.